I did hit it. There we go. So before we start section 8.4, we have a couple of problems I want to talk about. And first one here was the product of two trig forms. If I remember right, this became 4 times 6 CIS, and I added the two angle measures together. This becomes 24 CIS 390. But 390 is the same as 360, meaning I went all the way around plus another 30. Okay, so this becomes 24 times the cosine of 30 degrees plus I sine of 30 degrees. Okay. Shoo-ba-doo-ba-doo. I think the first test question is something as simple as this. If I give you a triangle and give you two of the sides, can you find like the tangent or the sine or so on and so on? This is 1 square root of 3, 2. By location, these all stay positive. This becomes 24 times. Let's see. I mean, this could have been a final answer depending on what they were looking for. But if I want to write it in complex form, the cosine is the square root of 3 over 2 plus I times 1/2. Throw that 24 through and I get 12 square root of 3 plus 12I. Jump around, jump around. That's a good proud problem for, almost all of chapter 8 here. This is going from a trig form to a complex form. We did complex forms back to trig forms quite a few times. You remember, this was my X, this was my Y. I needed to find R, and I needed to find theta. All right, good. Got the product. Taking a look at the quotient. I want to divide them. It was R over R. I'm even going to do 1/3. CIS of, instead of adding them, adding the 30 and 360, I'm going to subtract. This time it's going to be 305 minus 65. The 5s are going. I think I get 240 degrees, and I'm happy because this becomes 1/3 the cosine of 240 degrees plus I sine of 240 degrees. The bears. Forever in this course, I've said, draw the triangle, draw the triangle, draw the triangle. That's a highlight film. 240 is going to send me over to here. This is 60 degrees. That means this is the square root of 3, 1, and 2. By location, a negative and a negative. Looks like this becomes adjacent over hypotenuse plus I opposite over hypotenuse. Negative 1/6 plus I square root of 3 over 6. So I performed the operation, got an answer, nice and simple. From my from my formula, CIS 240. Then took that, turned it into its rectangular form. Okay, did I mess up anywhere? Oh, Chow likes all of the work. Okay, good. Before we go any farther, I want to go back to vectors for a minute. And sometimes the vector is floating in midair, okay? And in this case, this vector is at -1, +5, 1, 2, 3, 4, 5. That's its initial point. And 7, -5, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. That bad boy is out at the end. That's the terminal point. Okay. It's a vector. It's just floating nowhere, right? It's just, that's where it is. We know it has, we know it has, what did I have for vectors? I had the magnitude and the angle. But the magnitude I could come up with, but the angle's kind of difficult. So what I need to do is make this a corresponding position vector. I need to come up with a vector that this represents. So here's what I have to do. I have to take my initial value and I'm going to move it here. And as a result of that, where does my terminal point go? Because that would be my position vector. So I need to come down 1, 2, 3, 4, 5, and to the right 1. So I need to come down 5 and right 1, which means I need to take this point right here, which was 7, -5. I need to go, let's see, to the right 1. So if I go to the right 1, where am I going to end up? So from here, I went right 1. So from here at 7, I go right 1. I should end up at 8. Here I came down 5. So here I'm going to have to come down 5 more, -10. So now that vector, 8, -10, it's going to have the same magnitude as you can see. It's going to have the same angle measure. But now I'm able to calculate that angle measure, right? I can find what that is in there. I would do the tangent of x over y. So the initial point is -1, 5. Terminal point is 7, 5. The position vector means take this bad boy and move it so that it starts at 0, 0. And as you can see me drawing the picture, you're going, yeah, okay, I got it. And of course, if you had to come up with a formula, it's terminal minus initial, 7 minus -1, 7 minus the -1, -5 minus the 5. 7 minus -1 gave me the 8. -5 minus 5 resulted in -10. Questions? Do we like it? We don't like it? Should I make another one up? All right, Patrick loves the thumbs up. So if I have an initial point of 2, 3, and I have a terminal point of, let's see, -2, 5. What is the corresponding vector? Again, I have to, the position vector, I'm going to do something like this just for kicks and giggles. 1, 2, 3. I have that. It starts there and it goes to -2, 5. It goes up there. So my answer better look a lot like that. Hey, if I can remember that it's 5 minus 3 and -2 minus 2, and my answer is going to be 2, -4, that's great. If not, I may have to do some calculating. So I'm going to start here, and my final answer is going to be 2. over up to and over -4, up to and over -4. So my position vector, yeah, okay, good. I like that. Up to over 4. Wait, did I do that wrong? I did something wrong. Because that's the point -4 too. Did I write these wrong? I wrote them wrong. Dummy. Y minus y. Don't even look at that. Excuse me, x minus x. -2 minus 2. 5 minus 3. Yeah, there it is. -4, 2. -4 up 2. I found my position vector. What if I said, what's the angle measure? Well, this is -4, this is 2, this is theta. I would say the tangent of theta equals y over x, 2 over -4 kind of deal. What's its magnitude? Square root of 20. 16 plus 4 and take the square root of it. Keep doing the same types of things over and over and over and over. Yeah, yes, no, maybe.
Yes.
Keep rolling. Okay. So now 8.4, I'm gonna do this. If I said R CIS theta, which we're familiar with, yeah, okay, we got that. But this time I'm going to multiply it by R CIS theta. I'm multiplying it actually by itself. Okay, when I did the multiplication, my result was R times R CIS, the first angle plus the second angle. Equals R squared CIS 2 theta. Well, that's kind of all right. Anything times itself is like squaring it, right? Alrighty. Well, let's see if I do this. R CIS theta times R CIS theta times R, the excitement, CIS theta. Well, that's the same as R CIS theta cubed. Well, I already know what I get when I multiply the first two together. R squared CIS 2 theta. Now I'm going to multiply it by another one. And I'm going to get R squared times R cubed. I add the angled measures together. 2 bananas and 1 banana is 3 bananas. So if I start with that, I get that. I started with this. I got R squared 2 theta. I get R cubed 3 theta. What if I said R CIS theta to the nth power? What would I get? R times R times R times R times R n times R to the nth. Okay. Not sure where we're going with this. CIS theta plus theta plus theta plus theta. You know, if I took 6 plus 6 plus 6 and added them together, that's 3 times 6. If I took theta plus theta plus theta n times, that would be n theta. This guy is called de Moivre's theorem. De Moivre's theorem. All right. Way to go, de Moivre. Now, when am I going to use this? I don't know. What if I said to you, what is 1 plus 2i squared? You'd be going, okay, not too bad. This complex form is great. I can go 1 plus 2i times 1 plus 2i, and off I would go to find the answer. Yeah, I can do this. 1, 2i and 2i is 4i, and then that becomes 4i squared. That becomes 1 plus 4i. Now it's minus 4. Hey, negative 3 plus 4i. Not too shabby. What if I say, yeah, the FOIL, right? You just FOIL. Now, again, another term is double distribute. 1 times 1, 1 times 2i. So I distributed the I, or the 1. I distribute to 2i. And I'm all good. Now, what if in its world of bizarreness, I said, what is 1 plus 2i to the 21st power? You'd be going, oh, hell no. Oh, I can say that. No, I don't want to do this 21 times. Is there a faster way? Yes, there is. De Moivre's theorem. In order to use this, which is great, first thing I have to do is change this trig form into my polar form. Excuse me, this complex form into my trig or polar form. Ah, so you're telling me I can do this faster than writing this out 21 times? And the answer would be yes. Yes. Let's try one. There we go. Well, let's do this one first. Let's do this one first. Okay. Negative 2 minus 2i to the 5th. That would be, as I mentioned a minute ago, negative 2 minus 2i times negative 2 minus 2i times negative 2, 5 times. And I'm going, nope, nope, nope. First thing I want to do instead, I'm going to use de Moivre's theorem. I'm going to take negative 2 minus 2i and convert it. Excuse me, my pencil died. Excuse me. How do I convert again? This is just practicing something that we learned before. I have my x equals negative 2. I have the y equals negative 2. I need to calculate r and theta. R is going to be the square root of 4 plus 4, which is 8. Square root of 8 is 2 squared of 2. I like it. Theta, when I calculated theta, I went tangent of theta equaled y over x. I want to know, when is the tangent of theta 1? But I guess I do need this, because theta is going to equal the inverse tangent of 1. I like it. I love it. Everything's all good. It says I'm in degree mode. That's good. Always want to be in degree mode. The inverse tangent of 1. Excuse me, back that up. Negative 1. That is negative 45 degrees. Now, I also know, what the heck am I doing? That is a positive 1. Somebody's just about to catch me, right? And believe it or not, that ends up being positive 45. Okay. Going to back up a little bit. For this guy right here, the tangent of theta equals 1. How many answers are there? There's 2. Tangent is positive, and all spiders taste crunchy. All spiders taste crunchy. So there's 2 answers to this guy. But in my world of solving using inverses, this only ever tells me one answer. And again, this answer is 45 degrees. The other answer is over here at 225 degrees. And when I look at my X values and Y values, oh yeah, there's a difference. I don't want just 45. In fact, I don't want 45 at all. By location of where this goes on my coordinate system, this being the real part, this being the imaginary part, I want this 225 degrees. I was given the X and Y. I need to come up with the R and theta. So now I have 2 square root of 2 CIS 225 degrees raised to the 5th power. Raised to the 5th power. Let's see. I have the first thing is going to be to the 5th power. The second is going to be, oh boy, CIS 225 times 5. Let's see how we do this. Clear. Okay, 225 times 5. And that's going to be a big number, 1125. Now I know that number goes around, and so I'm going to do minus 360. Oh, that has the same terminal, minus 360, because I want to get into the range of 0 to 300. Oh, sweet. That's the same as, okay, 225 degrees times 5. Thank you, Demoiselle. That becomes the same as 45 degrees. This becomes 32 times, let's see, first time through this, square root of 2, square root of 2, square root of 2, square root of 2, and a square root of 2. Ah, that's a 2, that's a 2. So that becomes times 4 square root of 2. (128) square root of 2 CIS 45 degrees. Okay, I'm going to take 128 square root of 2. I'm going to let the calculator do its magic. 128 times the square root of 2 times the cosine of 45. And I'm going to get the number 128. Plus this time I'm going to take 128 square root of 2 times the sine of 45 degrees, and I get 128. Huh. Oh yeah, the sine and cosine are both 1 over the square root of 2. So okay. There you go. So negative 2 minus 2i raised to the 5th power is 128 plus I 128. That's a nice long mathy type of problem. Somebody comes and looks over your shoulder and they go, whoa, look at all that. Man, I'll never be able to do that. And you'll be going, yeah, that's right. That's right. I figured I know all this stuff. Try one more. Again, now that we're at the 8th power, yeah, oh boy. Convert to trig form, use demoiselles, get an answer, convert back to imaginary. Let's pause this bad boy. All right, let's take a look at this. I identify my X and Y as 1 and the square root of 3. I went and drew my triangle right away. And I went, oh, that is nice. Because my original X and Y is located here in the first quadrant. And when I went to calculate R, became 2. And I'm like, hey, that's my 60-degree triangle. So converting over to trig form was pretty easy. 2 CIS 60 degrees. And at any point you have questions, give me a holler. 2 to the 8th power, 2, 4, 8, 16, 32, 64, 128, 256. CIS 8 times 60 is 480. But when I subtracted 360, I get 120. Okay, I get 120 degrees. 250 times, oh, I drew my 120 degrees. That's a reference angle of 60. Square root of 3, 1, and 2. Check location, that becomes a -1. The cosine was -1/2. The sine was the square root of 3 over 2. 250 and 2 gives me a -128. 256 and 2 gives me a positive 128. I square root of 3. Cool. I got a thumbs up. Are there any questions on this? Section 8.4, de Moivre's theorem. You sit at the dinner table tonight and somebody says, what'd you learn in school today? I learned de Moivre's theorem. What?